All right, hey gang. Over the next couple minutes, I want to go over the chapter 1 review with you guys. I really hope that you took it seriously when I said do not watch this video prior to working on your homework, your chapter review, I should say. It's important that you, I'm going to use an agricultural term, get weaned off of my assistance and can do it on your own, okay? And so by you just kind of copying down what I'm putting down here and listening to me, while it might be somewhat beneficial, isn't nearly as beneficial as if you try it by yourself first and then just kind of check over it with this video here. So with that being said, I'm going to go ahead and walk you through the problems, and you can ask questions when you come back to class. All right, here we go. Let's get started. Taking a look at number 1, which pair of angles would be considered vertical? As I look through these angles, AFB, okay, and EFD would not be considered vertical. Remember, vertical angles have to have two lines that intersect, and they have to be opposite each other. So this angle here, the vertical to it would be this one right here, okay? This one has no vertical angle because this line has a kink in it. It's not a straight line. So it's two intersecting lines and the angles are opposite each other. Looking at letter B, AFG, this angle here, and GFC, no, they would be considered a linear pair. Together they form that straight line. So that wouldn't work either. If I have AFB and DFC, oh, those are vertical angles. They are opposite each other. So I hope that you put down letter C here for that one. Let me look at AFE. And then we have GFC, okay? Now again, this is kind of tricky, but this is not a straight line. That would be a line that would go head in this direction. And so as a result, these are not vertical angles. Which angles are supplementary to each other? Remember, supplementary means 180 degrees, okay? So two angles who add up to 180. If I look at AFB and EFD, okay? Now what's interesting about these two angles, they do form a straight line, but you're missing this portion of the angle, okay? If we're going to do 180 starting here, it has to go all the way around over to here, okay? So if we miss this portion of the angle, and we only have these two, even though together they make that straight line, it is not supplementary. Part B, if I do DFC, okay, so that angle there, and BFG, well, it's kind of the same situation here. These two angles have opposite rays, okay? They form a straight line, but we're missing this portion right in here of the 180 degrees. So again, that would not work. Letter C is AFE and EFD. Well, I think we can see here, if I start here and go over to here, from one part of the angle to the other part, that doesn't make a straight line, so that cannot be it. So it has to be D. Let's see here. BFG, okay, so that angle there, and DFG, yeah. So BFG is here, DFG is here, and you can see that we have 180 degrees there, that straight line. So hopefully put down again letter D there, okay? Use the following statement for problems 3 and 5. In the diagram, FA and FC are opposite rays. So right now I'm thinking 180 degrees. Opposite rays are 180 degrees. FA, FC. So this is a straight line right there, okay? FE, the ray, bisects angle AFD, okay? Now, again, what does bisect mean? This is one of the terms we've been working on. It means to cut in half. And when we have an angle that's been cut in half, we now have two equal portions of that angle. So I need to go ahead and mark them as being cut in half like this, okay? Now, until you get in the habit of doing that, in number 3, I say use geometric markings. That's what I just put in there to show the diagram that FE bisects AFD. So show that that is bisecting or cutting in half. Find the value of x if the measure, remember that M means measure, angle AFD equals 122, so this whole angle is 122, and angle AFE is 2x plus 11. So this portion of the angle is 2x plus 11. Now here's the deal. If this whole angle is 122, what does the measure of this part have to be? Okay? Well, 122 divided by 2 is 61 degrees. So you could go ahead and say that AFE, which is 61 degrees, is equal to 2x plus 11, okay? Or another possible equation, if you were to double angle AFE, that would equal AFD, okay? Do I care which way you do it? No. And then there's probably more ways. You could probably just 2x plus 11 plus 2x plus 11 equals 122. You could do 2x plus 11 equals 122 minus parentheses 2x plus 11. So there's lots of different variations of the equations, but they all get the same outcome, okay? So if I go ahead and solve this, I'm going to subtract 11 and get 50. And then I'm going to divide through by 2 to get 25. Okay, so x would be 25. Here, you could either divide both sides by 2 and get this equation, or you could go ahead and distribute it, which I think most of us would do. Okay, subtracting 22 then is 100, and then dividing through by 4 gives you 25 as well. Okay, so again, lots of different ways you can go about solving it. Just make sure you know one of them. Number 5, use geometric markings in the diagram to show that FG, remember what that upside down T means? Perpendicular. And do you remember what perpendicular means? It means to have two lines that intersect that form a right angle. Okay? AC. So if FG is perpendicular to AC, I'm going to go ahead and show that this is a right angle right here. Okay? Now, it says find the value of y if AFG, so this angle right here, is 8y minus 10, so that we have perpendicular there. So, well, AFG, does anyone know what the measure of this angle is? Well, if this one's 90, and this is a straight line, which we were told earlier right here, okay, I'm going to go ahead and I'm going to go ahead and say that this is 90 as well because it has to make 180. So my equation is going to be this. AFG is 90. And now I can go ahead and solve for y. If I divide through by 8, that should be 12 and a half. Okay? All right, now, the last problem on the page says this. Find the value of angle 1 if angle 1 is supplementary to angle 2. Ooh, so I'm going to convert that to equation here. Supplementary mean has a sum of 180. And angle 2 is supplementary to angle 3, or complementary to angle 3. And angle 3 equals 22. All right, well, I'm going to plug this in, and I'm going to go ahead and solve for angle 2. If I subtract 22 from both sides, angle 2 will equal 68. And if I plug 68 in up here, and I subtract 68, angle 1 will equal 112 degrees. Okay? So I know that this problem is probably a little different than some of the ones we've been working on, but it all comes back to do you understand what these terms mean? Okay, if you do, you can set up the equation, you can go ahead and solve. Okay? All right, let's move on to the back side. Story problem. Here we go. You are traveling from Findlay to Columbus this weekend. Columbus is located 40 miles east and 80 miles south of Findlay on State Route 23. 2 stopping points along your trip would include Upper Sandusky and Morrill. Upper Sandusky is approximately 2/5 the distance from Findlay to Columbus, and Morrill is half the distance from Findlay to Columbus. Note, every dash on the coordinate plane represents 10 miles. Okay, so we can get this down to 40 and the 80. If Findlay, point F, is at the origin, okay, so I'm going to put Findlay at the origin, F, which is 0, 0, okay, Let's see here. Identify where Columbus C would lie. Okay, now 40 miles east. Let's talk about our directions here. North, south, east, and west. Okay, so 40 miles east, 1, 2, 3, 4, and 80 miles south, 1, 2, 3, 4, 5, 6, 7, 8, 80 miles south. Columbus is at 4, -8. Okay. Now, I like to be kind of particular. You like to be particular when I graph these, so I am going to go ahead and do this right here. Okay. And that's the direction that we're heading. The first question is this: determine the distance between Findlay and Columbus. Well, as we've been practicing, if I go ahead and show the x and y value, x sub 1, y sub 1, and x sub 2 and y sub 2, okay, your distance formula, we should be able to work out to find the distance. Okay, so if we plug this in, x sub 2 is 4 minus 0, and y sub 2 is -8, and again minus 0. Y sub 1 is 0. Okay, so we end up with this. And then if we square these, no, you don't. When you square a negative, again, we leave the parentheses there, you get a positive. Okay, so just be careful about that. The reason I put that in there was because I know there's going to be somebody that makes that mistake. Don't make that mistake, guys. If we add 16 to 64, let's see here, 70, 80 gets the square root of 80. Okay, and then you can plug that into your calculators, and I'm assuming, oh, I do have a calculator. Let's see here. It's about to go dead. Square root of 80, 8.9. 8.9, almost 9. There's a distance there. Now, almost made this mistake. Remember, each unit is 10 miles. So if I take that 8.9 and multiply that by 10, we're talking approximately, I'm going to use the approximate symbol, 90 miles. Okay, 90 miles there. Sorry, the paper was kind of cockeyed as I was working through that, but I hope that made sense to everybody. What is the geometric term that would describe the location of a town of Morrill between Findlay and Columbus? Okay, now remember, Morrill is half the distance. What's the geometric term for half the distance? That would be midpoint. Okay, the midpoint would be half the distance there. Identify the town of Morrill, M, on the coordinate plane and identify its ordered pair. Okay. Now, you can do this in several ways. You can use your midpoint formula, and the midpoint formula is this: the average of the x's and the average of the y's. Okay, and so as I plug these in, we end up with this: 4 plus 0 over 2, and then, let's see here, -8 plus 0 over 2. So this ends up being 4 divided by 2, which is 2. -8 divided by 2 is -4. Okay, so we have 2, 1, 2, 3, 4. That is Morrill. Okay, so from here, describe how you were able to identify the location of the town of Morrill. You could have done the midpoint formula, and you can write that out there. Or you could go ahead and do this. If I go ahead and take my rise and run, if I was to go ahead and do this right here, this distance here is a length of 4, and this distance here is a length of 8. The fractional distance that we're coming up is half of both. So half of 4 would be 2, and half of 8 would be 4. 1, 2, 3, 4. Or you can do over 2 and down 4. Either way, you get the same location there. So you could talk about the fractional distance being half the rise and half the run, or you could end up talking about how you use the midpoint formula. Okay, just to say I've got the midpoint formula. All right, the next one, identify the location of Upper Sandusky, point U on the coordinate plane. Show your work on how you came up with the location of Upper Sandusky in the coordinate plane. Okay, so it's 2/5 the distance, what did it say? 2/5 the distance from Findlay to Columbus, okay? 2/5 the distance. So what I'm gonna do is I'm gonna take 2/5 of 8 and 2/5 of 4, okay? Now, when I do this, if I was to work this out, 16 over 5, 8 over 5, oh, doggone, you got fractions, right? This would be 3 1/5, or 3.2, 3.2, okay? And this is going to be 1 3/5, which is 1.6, okay? So as you work that out, hopefully you got those values. Now, how do I get this? Well, let's do the x value first. I'm actually going over 1.6, and I'm going down 3.2. 1, 2, 3.2. So Upper Sandusky, you know, if you think about it, 2/5 is actually 40%, okay, or 0.4, 40%. It's almost half. And so as a result, the location of Upper Sandusky here is going to be at 1.6, 3.2. Okay. All right. To finish this off, down here we have, zoom in a bit. Okay. Find the length of DE. Well, in order to find DE, we know that DE plus EF equals DF. The two smaller segments add together to equal the larger segment. Okay. Now from there, DE is a length of 3x plus 5. EF is a length of 5x minus 13. And DF is a length of 24. So all I did was plug in those values. Okay. Now we combine the like terms. So 3x and 5x would be 8x. 5 minus 13 is -8. Okay. Now I'm going to go ahead and add 8 to both sides. So you end up with 8x is equal to 32. And then I'm going to go ahead and divide by 8. So x is equal to 4. Okay. So if I want the length of DE, okay, I'm going to go ahead and plug in x, which is 4, and DE will have a length of 12 plus 5, which is 17. Okay. If you wanted to double check your work, you could plug it in right here. 5 times 4 is 20, minus 13 is 7, and 17 and 7 make 24. Okay. All right, well, I hope that all made sense to you as far as what we did in the review. Like I said, bring questions tomorrow if you have any. Otherwise, have a great night, and we'll see you the next time you're in class. Thank you for listening.